Hi, hello students. Welcome back to the YouTube channel. In this video session, we are going to learn the data transmission, which is chapter 2 in computer science, IGCSE. In this chapter, we are going to cover that this video session methods of transmissions, which are parallel and serial. That means how many number of bits are going to transmit. That is the methods of transmission. Directions of transmission. There are three different directions are there. Simplex, half duplex and full duplex. Full duplex is also known as duplex transmission. And the third one is synchronization of transmission. How the sender and receiver are synchronized. So these three are the major factors which needs to be considered while data is transmitted. So obviously when the generation has started using computer, we all are forced to transfer the data between devices, right? So you may send an email, you may copy the files from pen drive to computer. Anything is called transmission, transmitting data from one device to another device. So how are the ways, what are the ways you are transmitting data? Only two ways basically: wired transmission, wireless transmission, right? So that is clear, isn't it? Yeah. So whatever transmission medium we are taking, these are the three factors which needs to be considered: methods, directions, and synchronization. Okay. So in this video session, we are going to cover these three particular areas. Okay. So we will come in detail. Okay. So first we'll learn what are the methods of transmission. As I mentioned in previous slide, two methods are there, that is parallel and serial. Yeah. Okay. So first thing, the serial means, you imagine in a road, that is a one-way road. Okay, one-way road, and one track is there. How many cars can travel in one track? Obviously only one car, right? If the second car wants to travel, what they can do? They can go behind the first car. So the same way, serial transmission will transmit one bit at a time. Okay, only one bit at a time. It doesn't mean it can transfer only one bit. It can transfer many bits, but at a time only one bit it will transfer. So that is serial transmission, one by one. And what is in the parallel? Imagine in a road there are 8 tracks. So how many cars can travel at the same time? 8 cars can be traveled, right? So the same way, parallel transmission will allow you to transfer multiple bits at the same time. Okay. So sender is there, receiver is there. If it is serial transmission, one by one it will transmit. Bit 1, bit 2, bit 3, like that, right? But when it comes under parallel transmission, all the bits will transfer at the same time together. It is in a group. Okay. So that is parallel transmission. Hope it's clear. Got some idea about serial and parallel transmission. Parallel transmission allow transfer of multiple data bits at the same time. And it doesn't mean that parallel transmission wires are in different cases. All this, say for example, now how many wires I am drawing here? 4 wires, right? It won't be looks like this. These 4 wires will be in a single case. Okay, so the connector will be here, another connector will be here. This 4 wire will be sealed inside a case. So that is a parallel transmission. This can transfer 4 bits at the same time. Okay, parallel transmission allow transfer of multiple data bits at the same time over separate media. This is separate media 1, 2, 3, 4. But doesn't mean this is separately installed. These all together installed once. So in general, parallel transmission is used with a wired medium that uses multiple independent wires. Still it is independent, but all are synchronized in the same time. Okay. Look at this picture. What it shows, the sender and receiver are here, right? In this diagram, how many bits can be transferred? 1, 2, 3, 4, 5, 6, 7, 8 bits, right? So this normally the computer parallel transmission takes 8 bits at the same time. The latest technology uses 16 bits, 32 bits, it will go on. But 18 bits at the same time, that is a obvious data. What is meant by 8 bits? We have learned in that previous videos. What is that? Yeah, it is 1 byte, right? So usually a sender transfer 1 byte at the same time is known as parallel transmission. Okay, imagine how the serial transmission will transfer all these 8 bits. Yes, first 1 by 1 it will transfer. Okay, yeah, look at this picture. Here it is. Sender, receiver, single wire. This is a single wire. So how many bits it can transfer if it is a single wire? Yeah, it is only 1 bit it will transfer. So if I want to transfer 4 bits, okay, here the first bit will transfer. Once the sender transfer and receiver receive, the next bit will transfer. Once it is transferred, the next bit will transfer. So 1 by 1 it will transfer. So now from this you understand which one will consume more time, parallel or serial. Yes, obviously serial transmission will consume more time, right? Okay, so in order to learn parallel transmission, here are some points we need to specify. The parallel wires that each carry data, parallel interface usually contains other wires that allow the sender and receiver to coordinate, which means a kind of buses. Okay, that some other cables, which means if you're saying that 8 bits you want to transfer using parallel transmission, it doesn't have only 8 cables. There may be more than that. What is the use of other cables that will coordinate how the data needs to be transferred? Okay, the second thing is installation will be easy. That is what I mentioned in the previous slides. Even though 8 cables are there in a parallel transmission, all these will be in a single physical cable. Okay, it doesn't mean 8 cables will be installed separately. These 8 bits together it will install only once. That is what I mean. Okay, and parallel transmission is high speed since n number of bits will transfer at the same time. That is, serial transmission will be slower than parallel, right? And most of the computer hardware, the internal components of your computer, works with parallel transmission. So here one more point we need to specify. So if you want to connect a device from one building to another building, according to the cost effective, which one will you prefer? Whether you will prefer the parallel or serial, right? You want to connect a computer to a printer which is located into the next building. So which one will you prefer? Which one will be expensive? Single wire is expensive or multiple wires are expensive? Yes, you're right. So the serial transmission will be preferred since it is long distance. Hope it's clear? Because if I want to extend a cable for 1 kilometer, if it is serial transmission, only 1 bit is enough. That is serial transmission will be enough. 1 cable I have to install. At the same time, for 1 kilometer, if I use parallel transmission, we need to install 8 cables, which is expensive, right, compared with serial. So that serial transmission will be slower, parallel transmission will be faster in transmission. So which one is expensive and which one is cheap? Yes, serial transmission is a cheaper one than parallel transmission. So that the internal part of computer hardware, they prefer parallel transmission for high speed transfer, right? It doesn't have the long distances, very few millimeter or centimeter distance will be there, right? So that internal part of your computer, they prefer parallel transmission. When it goes long distances, which one will you prefer? Yeah, it is serial transmission. Okay, let's get into serial transmission. Since one bit at a time, it may seem that anyone would choose parallel transmission at high speed, right? Most communication systems use a serial mode because the most of the communication system will be separated according to the distance. The devices will be separated. There are two main reasons. First, serial networks can be extended over long distances at much less cost, right? That is what just I mentioned. If you want to connect your device from one building to another building, you should go for serial transmission since it is less cost, right? The second one, physical wire means that there is never timing problem caused by one wire being slightly longer than another. One more thing I forgot to mention here is, okay, so imagine serial and parallel transmission. You are clear in that, right? So some cases parallel transmission will transfer. Assume that there are 4 bits it is transmitting. Okay, 4 different cables are transmitting 4 different bits. 1, 0, 1, 1. Okay, at the same time all the 4 bits are traveling. Which transmission is this? I am asking you again. It is a parallel transmission. 4 bits are getting transmitted. While transmitting the data, suddenly one cable got corrupted. So what are the bits the receiver is going to receive? Yes, this one the receiver is not going to receive. The data which receiver received is 1, 0, 1. This one, 0, and this one. So obviously the receiver received the wrong data. Hope it's clear. So this is called skewed. The data will be get skewed while using parallel transmission. So there is a chance of error. Keep it in your mind. When you use parallel transmission, the device uses parallel transmission, there may be possible of errors. But when a serial transmission uses only one wire will be used, there is less chance of errors, right? Because one by one will get transmitted. The first bit is getting transmitted. After that, the second bit will get transmitted. One by one, it is there. So there is a less chance of errors. Keep it in your mind. Is that clear? So that is another point I forgot to mention here. Sender and receiver must contain a hardware that converts data from parallel. Yeah, parallel to serial, serial to parallel converter is needed. Okay, which is not visible in most of the cables, but there is a converter which is used by sender as well as receiver. Say for example, sender is transmitting a parallel transmission, but the cable is serial. So this will transmit parallel to serial. Then the data will transmit. Then serial to parallel. Okay. So there is a need of converter, hardware to convert between internal parallel and serial. Okay. So I repeat, how many cables the parallel uses, how many cables the serial uses. Yeah, serial uses single cable, parallel uses multiple cables. So look at this picture. How the data are getting transmitted from sender and receiver. Okay, the right side it shows sender and the left side it shows receiver. MSB stands for most significant bit, least significant bit, okay, or lowest significant bit. So most significant bit will transmit first. Clear? This 0 will get transmit all together in parallel transmission. All together will transmit at the same time, isn't it? Right? But in serial, here it shows most significant bit will get transmitted first. Once this data received, the next bit, the next bit, next bit, next bit, each one. Each data will transmit. Okay, that is serial interface. Hope it's clear. Most significant bit will transfer first. But in parallel, all the bits are getting transmitted, right? Okay? Yeah.